So, 5.2, this is where we started. We'll talk about where we were as we progress to where we've been. Also, heads up on the board there, what's it say after our 5.2 objective on Monday? What's it say?
It says
begin 5.3. So heads up, the plan is for us to finish 5.2, have some more time, and then start 5.3. Just for a little bit at the end, get a bit of a head start again. Okay? So that's kind of the plan and the target I have today. So just heads up on that. So don't be alarmed when we begin plan to begin another section at the end of class. Okay? So 5.2. This is where we were, preparing for where to go, and where we're going. So we talked about angle bisector theorem. We said angle bisector. If a point's on the bisector of the angle, if point D is on the bisector AD, then it's going to be equidistant from the two sides of the angle, AB and AC. And we measure that distance along the perpendicular. That's the point I just drove home during our warm-up. And then we have this converse where we said, hey, if a point is equidistant from these two, we measure along the perpendicular and inside the angle, then it's going to be on the bisector. Talk about that. Then we progress to saying, hey, do we know whether whether point C is on the bisector of angle A? We said here, yep. We did this together, right?
no.
Oh, okay, my bad.
Told you we sort of did it.
Oh, yeah. Well, we'll do that now, my bad. So, on number 1, do we have enough information to say that point C is on the bisector of angle A?
Yeah.
Okay, yes, you saw it up there, right? Okay, why do we have enough information? What do we know?
Because it has two right angles.
Okay, we're measuring along the
And
perpendicular,
they're equidistant.
and it's equidistant. Good word. Equidistant means the same distances from each. So we know it's equidistant by it saying 3 centimeters and 3 centimeters. You know, those are the same number, so they're congruent. So yes, it must be on that perpendicular. It must be on the angle bisector rather, because it's equidistant measured along the perpendicular. What's that, Kennedy? No. What's your question?
I know, I don't even know where we're at. I
Okay, we're on,
got the wrong note packet out.
okay, we're on the first page of Thought Chapter 5. We're on the first page. Excuse me.
Yeah.
It's-
On the
it's
third.
both.
Third page.
We're on the third page. Thank you.
Okay,
Like
thank you.
if you flip through it.
Got it.
Okay. And we're about halfway down. Okay. So, number 2. Do we have enough information to conclude what's on there? No. It's not equidistant, right? This one's 4 centimeters from here, 2 centimeters from here.
That's the point.
So it doesn't matter that it's a right angle because they're not the same distances. So no, even though it's the right angle, it's not the same distance. It's not 3 and 3, it's not 4 and 4, 2 and 2. One's 4, one's 2, different distances.
Like, oh, because they're different.
Correct. That would be our reasoning. Yep. They're not. It's not equidistant from the two sides of the angle. And then on 3, do we have enough information to conclude it?
No.
Why not?
They're right.
We don't know the right angle there. Okay, we aren't told what kind of angles they are.
There is no right.
There is no right angle there, so we don't know whether they're measured along the perpendicular. So it's the same distance, but we don't know it's the right angle. Now, what if I had this brought up before? I had this brought up before in a different class where they said, hey, but this point you can tell it's off the bisector. Well, so I had the question raised, what if we didn't know that anymore? What if we were actually told, well, it's actually going to be like perpendicular to this right here, and it's going to be like a length of 2, and it's going to be perpendicular to this right here, and let's just say that's a length of 2. Would we then be able to say it's on the bisector? Yes, even though it doesn't look like it is, if this is what we're given, we could say it is. Even though it doesn't look like it, if we're given it's a right angle to those sides and equidistant, we would know. But
You can tell.
that's not what we were given at all. It's not what we were
So
given.
we know because why? No right angle.
It's no because we don't have this measured along the right angle. Even though it's equidistant, 3 inches, 3 inches, it's not along the right angle. So it's the same problem we had during our warm-up. Or the same issue, I should say. Not the same problem, same issue. What?
Alright, so 3 and 3 equals 6.
3 equals 6. That's true.
Good job.
Okay. Questions on this example? Example 7, part 1, 2, and 3. Okay, hey, let's move on to example 8 now. Okay, so if we want to try and find the measure of CD here, CD is right here. What do we know about measure CD? It's congruent to BD. So if this is congruent to this, what could we do with these measures? Set them equal. Whenever we hear congruent, we should be having cowbells going off in our head like an alarm saying set them equal. So 6x minus 7 is equal to what? 3x plus 5. Go ahead and write that down now. So, yeah.
Okay, is it weird that geometry makes algebra easier?
I think it puts it in perspective.
Because I never understood any of this, and then you explained it to me once while we were doing triangles, and now it's like super easy.
There you go.
Find the angle, right?
We're trying to find CD. And what kind of thing is CD? What's it say? It's a segment. We're trying to find the length of segment CD. So what we're doing is we're saying since these are congruent in this picture, since the angle is bisected and point D is on the bisector, we know it's bisected, it has to be equidistant from these two sides at the perpendicular, and we know they're congruent. So we set them equal. What would we do? What's a good first math move here? Sophia?
Okay, so what I did was subtract 3 from both sides.
Okay, subtract 3x.
Yeah, 3x.
So 3x minus 7 is equal to 5. Abby, what would you do next? Add 7, okay? So we get all the x's together. Now we need to get all the constants together, but away from the x's. So 3x is equal to what number? 12. So now we have one more math move left to solve for x.
I know that you
Divide 3 from both sides.
equals 4.
Are we done? Oh, I heard someone say it.
No.
We gotta plug it in. Where do we gotta plug it in?
3x plus 5.
17.
I heard either one. Why could we do either?
Because
They're congruent. It's the same measure. Do we have a preference between these two?
3x plus 5.
Okay. Why 3x plus 5?
Because 3 times, we just did 12 divided
Smaller numbers. Marley said, hey, smaller numbers. Would you rather multiply by 3 or multiply by 6?
3.
3. Would you rather do addition or subtraction?
Addition.
Usually addition. This one has smaller numbers that you multiply by, and it's addition. We generally prefer that. We could choose either. And it work. But this is the way to make your life a little easier if you catch it, okay? So if you catch these things, try to make your life a little easier here. So you can put it in the top one. What's 3 times 4?
12.
And 12 plus 5 is 17. So what we would say here is that the measure of segment CD is equal to 17. And that would be our answer. I mean, it couldn't have gotten worse, right? It could have gotten worse. I'm not saying it's not as bad as I thought it was, so I'll take it.
I still have kindergarten handwriting.
You still have what?
Mine is so bad. Yeah, it's not as bad as my brother's though. My brother's is terrible.
No, your brother's is Scarborough.
Okay, I think.
Yeah, it's literally
Wow.
terrible.
It's true.
So is it like a fact that boys' handwriting is always worse than
No.
girls'
It's
handwriting?
lefties, I'm telling you. Sorry, but I'm left-handed.
It's typically more common that boys have worse handwriting, but it's not always true.
My little brother's handwriting looks like a serial killer.
I
Not even kidding.
don't even know what that
does
means.
a serial
Hey, example 9! Example 9, let's move on. Okay, we're told that this point, do we know this point is equidistant from these two sides of the angle?
Yes.
Yes, we know they're congruent by these lines and it's measured along the perpendicular. So what must we know about this angle?
That it is acute.
It is
Equal.
bisected. These two parts are equal to each other in measure. Okay, because we have this point that is, this point that is equidistant from the two sides along the perpendicular, it has to be on the bisector. So that means we know that these two measures are the same measure. So, Lily, what can we do if we know these two measures are the same? We know these two angles are congruent, we can set them equal. Awesome, that cowbell's going off. 2x plus 5 is equal to, sorry, 3x minus 5. Yes, Carly.
Is there ever a time where we add them together?
We added them together when angles were supplementary before, like the angles of a triangle or like stuff like that. But if things are congruent, what we'll do is we'll set them equal. So when two measures are congruent and we're trying to find a variable, we'll set them equal. Whenever they're congruent, we're trying to find the variable there, we're trying to set them equal. Good question. Let's subtract 2x from each side. 5 is equal to x minus 5. What can we do now, Max?
We could add 5 on both sides.
I think it's a good math move. So we have 10 is equal to x. Hey, do we need to do any more from here, guys?
Yes.
No, here's plug it
It
in.
says find x.
Oh, it says find x. Did we find x, Nathan?
Yeah.
Ooh, this is why we read. This is why we read instructions.
Yeah.
If we plugged in, would you have been doing extra work?
Yup.
Yeah, do you need to do that extra work?
No.
No, let's not then.
Good though.
Okay, we could. Marley?
Wait, if you're subtracting 2x, wouldn't that be negative 1?
Nope, because 3 minus 2 is 1.
Oh,
It's okay.
my bad.
Life happens. Questions? Other questions on 9 though? Okay, yeet. So on 10, we know the angle is bisected, correct?
Correct.
This is all dealing with angle bisectors. We know the angle is bisected, so we know that this point must be what? Equidistant from these two sides along the perpendicular. So what do we know about these two segments?
We have to add them together. They
They're
equal each other.
congruent, so they equal each other. 7x plus 3 is equal to 8x. Kennedy, what would be your first math move? Hey.
Hey! I'll keep her control next time.
Okay, awesome. Thank you, Nathan. I
Gotcha.
appreciate it. Look at our other ones.
Minus 3.
We could, but what was our first step in our other ones? Subtracted what? Yeah, we subtracted the smaller x, right? So what do you think?
Only.
Okay, so what might we do here? Subtract 7x. So let's get all our x's on one side. Let's focus first on getting the x's on one side. We have 3 is equal to x. Hey, did we solve for x?
Good job.
Yeah. Woo!
Hey,
We're done. Okay? But, let me get you. Actually, you just want to come over here and study home? But let's not only come in and here study home, okay?
Well, you know, if you could do those problems like that for the test, it'd be golden.
Yeah.
Right now.
Okay.
Yeah, green.
Hey, thanks. I appreciate it.
baby.
Hey, Hey, so remember how we did this construction last time? You guys remember doing triangle construction last week? That was Monday before our snow days. Okay, we're gonna try it again, okay? Hey, what did I say about our compasses last time? Are they toys? No. They are sharp and pointy and can hurt people. They are not toys. Do not treat them as toys.
What day is it?
We did it on Monday.
It is the 27th.
So,
28th.
I'm gonna have you guys partner up again, okay?
What up, partner?
So,
I don't need a partner. I have my own.
okay.
Fancy.
So 2, 2, 2, 2. I'm gonna have you guys partner up anyway. 2, 2, 2. Grace, you'll have to go to this tablet, okay?
Oh, right.
Matt, no, you're
Yeah,
nice.
and you also learn the dates of their matches once. I taught her in Spanish and English.
So do we just start doing this out of nowhere?
Then you turn around.
Yeah, you're very remarkable, baby.
Mr. Foss, do you just want us to start?
No,
No, let's start.
I want you. I just gave it to whoever I said.
You don't like me?
Yeah, that's it.
I told you.
One more high five.
I never
No.
have them up.
Can I get a volunteer to pass these
You know
things
they're
out?
Spanish.
I
It's the
will.
same
Hey,
thing.
thank you, Kennedy. Here, I'll give you half and I'll give you Kennedy half, okay?
Yeah, that's all I did too.
Bye, music. I just asked if I could do
You guys remember when like
Does everybody get one?
Yep.
Oh, we all need one? I got one jar.
Mr. Foss,
Wait, does everyone
you down where we are. Yeah.
Oh, okay.
That was unclear. I was unclear about it. Thank you.
So everyone gets one?
Yeah.
You put on any, right?
Okay. So let's listen up. Okay. So now, I want everyone following along, whether or not you currently have the compass in your group, I want you following along. Okay. So what we're gonna do is we're gonna follow these instructions. First, place a compass on a vertex. What's a vertex? The point where an angle, the sides of an angle come to meet. So here, point A is an example of a vertex. That's what we'll be working off of. Working off of. So we'll have our compass here. So I'm gonna put my compass, one point, you'll put the sharp end, then that doesn't move, on there. Then we'll pick a setting, and you want it to be a smaller setting. So I'm gonna pick like this one for now, for example.
Oh, really small. So it doesn't
Kind of
have to be
related.
like open?
It doesn't have to be huge, okay? And now look how I swung through both sides of the angle, okay? I didn't have to make mine a full circle. I didn't have to make it huge. But I swung through both sides of the angle there. I want everybody to go ahead and do that. So do that now and then pass it to your partner and have them do that. Okay? So once again, put your point on the vertex there and choose a somewhat small setting, not huge, but you don't want it to be like extremely small either. Just kind of based off about how much I did. And then swing through both sides there. You want it to touch or cut through both sides there. It doesn't need to be much bigger than that. Just needs to cut through both sides there.
Oh my gosh, why is it choppy?
If your compass is moving and you find that the setting's changing, you can try and tighten it by hand on the side there.
If you take it by this side
You
of
want
the
me to go
compass,
sharpen?
look,
Everybody look at Mrs. Haswell.
you take it by this side of the compass and hold it by this side of the compass, set the pointy part down and move the paper, not the pencil.
Oh.
Yeah. So if you're having a hard time, try moving the paper like Mrs. Haswell suggested and keeping your compass stationary and holding that pointy part. That can help. Yes, and it can also help to move some other stuff off your desk if you need more room to spin it. Okay? So, what we're going to do now is we're going to put the compass, we're going to put the pointy part on one of the intersections. So it intersected both sides of the angle. Both sides here of the angle. We're going to put the compass on one side of it. And what we need to do is we need to choose a compass setting now that is going to be over half of this angle length, over the angle measure. So I'm going to put mine about here, for example, and you draw an arc. You draw an arc on the inside of the angle.
So we don't want it to be like too much bigger than the other one?
It can be, it doesn't have to be the same size as your other one. It doesn't have to be your same size as your other one. It can be a new size, but this is the one you want to keep measure of. And so what you'll do is you'll swing through and make an arc on the inside of this angle. On the inside of this angle here, you'll make an arc.
I've been in the art.
Okay?
No.
And then you need to keep that same setting. You have to keep the same setting for the next one we'll do. So the same setting we did here, you have to have the same exact setting for the next one we'll do. Because we'll go over to the other side on this intersection, and we'll do the exact same thing facing the inside. So it should be the exact same setting facing the inside.
You know what also?
Yes.
That reminds me of like labyrinth or something.
So
It looks good.
yours needs to be a little bit bigger. So this, when you put your compass here, this needs to be bigger. So you need this to come out wider. And then do the same thing for the other side. That makes sense, Julia? Okay. Yes, Rich.
I did that, right?
Yeah.
I'm sorry. I'm good.
Whenever I go to the other side, it doesn't cross. It won't.
I tried so hard. My pencil's janky. But
They have
it's
to
so
be
easy.
like even if it's like
It's Canadian video.
in math.
Okay, so what has to be the same size here, two of these have to be the same size. The two that have to be the same size is when you had your compass on the side of the angle. When you had your compass on the side of the angle and swinging inward, they have to be the same size. So the last two we did have to be the same size as each other. Okay, the last two we did have to be the same size as each other. Gracie, you want to go back to the seat right where this is? That'd be awesome. Thank you. You guys move all your stuff as your
I'm just gonna point out that we got the worst compass out there.
Yeah, ours is really janky.
so, I've over here trying to like move my paper. Like,
Oh.
I think it's. Got one.
I'm so lost.
I'll go put this one. Uh-oh.
Maybe. So.
Got me.
Here comes the point part. So we need a setting. That's. You want to
Did you erase it? Are you starting over? Okay, is this one better? Hopefully better. Guess what I had? Friday night I had wings. Saturday I had wings for lunch. Buffalo. And then Saturday night I had hamburger. But I ate a salad and I bought myself a salad because I felt fat. Yeah, it was really good. And then last night I had enchiladas. Pork was so good. Did you run or drive?
Now, this side. You guys settings. I am in the basement. Try that.
I have a whole basement to myself.
She made,
But as I
So
want
I'll just.
Okay.
So good. I had a salad.
Wait, does it have to be spelled like
No. It's a little, I think it's a little bit easier for us to know. Okay. Hey, so let's focus back up here, okay? Focus back up here so phones and other stuff away. Now when we have these two intersections here, we have these two intersections formed by our last two arcs we made. What we want to do is we want to use our straight edge, the ruler we have. We didn't have anything via straight edge. We have rulers right now. And we want to cut through these 2 points.
Could you go right through the middle of the point up there?
Ideally, yes.
Okay.
So mine was just slightly off. Mine was slightly off, but it should go right through the middle of this point up here.
Mine was slightly off. I always mess up on like these things at the bottom of lines.
The arrows,
Yeah, I can't do it.
these things.
And then it like bothers me.
So you should use your straight edge to connect those two intersections formed by your last two arcs you made. And you should get this line I made here.
Way better.
Yeah.
2 points, Scott.
It's true. Yep, that's good. Alright, does anybody need help getting to this point? Okay. Hey, what did we create here? Where does this look like it goes?
Through the bicep.
It looks like an angle bisector. It should bisect this angle. It should, if we do it correctly, bisect that angle. It should cut the angle in half. Okay, just like last time we talked about perpendicular bisectors. Why don't I connect what? I just don't, that way we can see there's one arc on each side of these. But we could. Okay. Questions on that? Okay, what we're going to do is we're going to do the same process. Hey guys, remember last time we did the perpendicular bisectors? We did this process once and then we did it 3 more times, right? For a triangle. So just like here, how many vertices are in a triangle? 1, 2, 3. So we're going to do this 1, 2, 3 times in the triangle right below it. What I recommend you guys do, is watch me do the first 2 and then begin. Okay, what I recommend you do is watch the first 2 and then begin. So I'll go to the top here again, and I'll pick a setting that's not huge, but it's pretty sizable, I suppose. Okay, and I'll intersect both sides of the angle, both sides of that angle there. Then I will go over here and put it on the intersection of the side of the angle in the arc. So here, then I have to choose a setting to where it's going to be over half of this angle measure, but it won't be the full thing. And then I have to choose the same exact setting. I have to make sure I keep the same setting as I go over here and put it on the other intersection. I swing through again, make the arc, and if I didn't mess it up terribly, that would look a lot better. Let me try that again here. messed it up quite a bit.
That looked good, I thought.
It was pretty off. I wasn't happy with it. I think part of my issue is this thing sliding around.
Now it looks.
Oh, now I don't have it matching. Okay, so we go through here. I connect these lines. And here you're going to want to extend it quite a bit, okay? You're going to want to extend it quite a bit. Create an angle bisector.
I know. I can't be doing that.
I've practiced a lot.
He goes and fixes the line. Even though
Well, I wanted to do a different color. I was a little more off on that one. So then, we do the same exact process, restarted on a different angle. Which angle do you guys want to pick? Bottom left or bottom right?
On the right.
Okay, I heard bottom right for now, so let's do the bottom right one right now on mine. So I'll go over here, I'll choose a setting, it doesn't matter what setting I choose. It doesn't matter if it's the same one I chose before or different, it's a different angle. New angle, new me, right? Okay, then you go over here, and we're going to pick a different setting, completely different from anything we did, doesn't matter. Could be the same, could be different. And you'll put it on the intersection. We'll go over here to the other intersection of that same angle, and we have to choose the same setting as we did for the first intersection of this angle. And we do the same thing we did on the first vertex. We create the line going through, create a straight edge,
Pretty much what's going on your fish that a kid drew.
basically.
We do.
So now, look how much I extended mine.
all the way out.
I extended mine all the way out, okay?
It's gonna have to.
And notice how mine intersected, they should. I want you guys to go ahead and do all three. I want you to do all three angles, and as you have questions, please raise your hand to ask. And when you do all three, and as you have questions, please raise your hand to ask.
No, that one is.
And you can ask your partner questions too. Part of the reason you're partnered up.
Yeah.
I don't know why it's so. Mine was fine. It was a little janky.
That's the spirit.
There's no possible
it's
way
made-
that this thing gets small enough to do these.
Can.
She's.
Maybe you need to make your first arc a little bigger then.
She's not.
So if you're having a hard time getting a small enough measure for the arc I'm going over right now with my pen, you might need to make a bigger arc. This first arc for the angle might need to be a little bit bigger. If you make that first arc for the angle a little bit bigger, you have it on your vertex, that might help it out.
Where did Nick go?
Did you let Nick go to the bathroom too?
You have an ROTC thing.
Whose phone is that thing?
Oh my gosh, no, I did that.
Oh, it is good. Thanks. You gotta do that one. You gotta do that one. Okay. I'll go.
I need help. And I also have to do research. Yeah, I don't think I'm doing
It's somewhere in my blanket. This is my lunch. Yeah, I did. Cody said the meat was good. It was. They're kind of spicy. I don't think you should eat spicy. No, she's
So if you keep going, there you go. Now go to the other one, do the same thing. They should be able to intersect.
Then go eat. I don't want to hear it.
know if I told you this.
Is mine really big? Is mine really big? Mine just looks really big.
Oh, what?
Kenny, are you doing it? Good job. I'm proud.
So, this one makes sense. You did it. Did you do that?
Yes, I did. I just have to wait for you to do it.
So here, we'll go to this one. Do the same thing. This point.
long.
Arc swing through. Okay. So try to erase some of these a bit more. Let's go to this point. Let's go ahead and fix on that.
Okay.
So put the point on that on the
Do I have
vertex.
to make a whole circle?
Just make an arc.
Well, we have to do this on the test.
Maybe.
Oh, please.
Okay. So now you'll put it on this intersection of the angle on the side. Yep, 21, and then you have to get it before you go. Let's make these. So push together. Yep. And use that to swing it.
Mine looks really messy.
So you'll have to kind of like angle it. So
I can't even read
so
it.
it's okay if you kind of
I don't
this
even
way.
know what happened.
That won't.
Actually, why is it okay?
I don't know, I'm gonna erase this.
Just make sure that this point is still touching the paper.
Make it right again, child.
Keep going, keep going.
Chasing something.
No, the roots are all the way there.
Nathan.
Sorry, I'm in the
So now
tense.
you go to this intersection. So you did this intersection now in the first arc. You made
You're not
this
gonna
side. You go to this intersection and the first arc you made it this side. And you did the same thing and worked it. So you should have two intersections.
Erase this line and start fresh.
Can I repeat that on the other
I don't know what that line is.
Yes.
Yeah, I did that.
So
I'm just trying to do it.
do that.
No, you're good, you're good. I just don't know where it came from.
Two intersections. There you go.
There.
Two intersections. That one, so you got a little bit off there. It's probably a half inch.
That's all.
Just put it, we'll pretend we did it now. And you'll connect those two straight edge. Okay. So,
What?
put a point.
Kind of makes me want to vlog it.
Oh, you got that one.
Oh!
Okay.
I have to write this line up.
Okay, for your first one doing it by yourself.
Oh,
That's close
shoot.
enough.
I don't know if the line is there. No, I actually don't like this part like split.
Okay, I don't know what I'm doing.
I think I did it wrong.
Huh?
Smaller.
I'm doing it.
I don't like to go smaller. Like that?
Yep.
Circle it.
Oh, what?
How do I put this back together?
Right here? Same setting? Yeah.
Straight edge on those.
My nose is running.
Yes.
Did I miss? Oh, because I need to. My lips are jabbed. Okay, lip lines.
Yay.
My mouth is
Every time I hear that, I always
I mean, it's a little rough.
Keep going along.
Oh.
Okay, keep going along.
Wow. Do you like not make it too
Yes.
I'm not messing up now.
it's like a cartoon version, like
Am I doing something wrong?
Does it matter the setting?
Am I doing something wrong?
I feel like it gets you.
What? Like, should I just choose a
I was moving off too.
I think this is young man.
How did she get? Oh my gosh, Tracy.
You left the bathroom before.
go?
I'd go upstairs.
Why?
To get something to send on my phone.
Uh-oh.
I was seeing how Randall's doing.
Okay.
I was being nice.
Sorry, I didn't mean to snake you. I was just wondering.
There we go. It just looks.
But I actually did go back.
Not another incident like McLean's.
I was gonna say.
This one we're playing. Did he tell you that too?
Well, yeah, I watched it.
Wait, what
What
happened?
He's always talking crap on me.
What
You guys
happened?
ever talk about teachers?
Yes, all the time.
Only the ones I don't like. So they do.
Oh,
I
yeah,
know.
yeah,
So you guys talk about
Wait,
students.
Carly,
at
what
lunch,
happened to Mr. Miss Chapman?
about us being
Okay.
bad.
I mean, sometimes
I was
bad
like,
is good.
Have you
Sometimes
talked
bad.
about me?
Yeah, have you talked
I
about
was
me?
just like walking around because I
I
wanted
remember
to
that specific story because it stood out.
Cause what?
Oh, what did you do?
I'm curious.
Okay, it wasn't that
I'm
bad.
curious if Mr. Cross.
I came
Oh.
downstairs with Randall, like,
Oh,
walking around.
That's where it happened.
Third time's a charm.
But he like freaked out.
Okay, so
Randall in?
I think I can do it
No,
with the
Mr.
opposite
McLean.
way.
He like screamed at her. I was like,
Yeah.
we were walking
You're
around.
supposed to go on that intersection.
I was supposed to be in the bathroom.
So, okay, we're gonna
Well, that's why he yelled at you.
This is the Archimedes one,
wandering
right?
around,
So,
and
what
something
you do.
happens, we think you're in the bathroom.
Okay, I got told we were supposed to be having like a fire
That's not my
alarm.
thing.
You gotta go to the bathroom.
First I heard of it.
Oh, that's responsible for
So
what
then you put it
Who
here.
told you?
you're doing. If you're not on where you're at, then you can't be responsible.
Sometimes you see like three.
Well, then that means that
Okay. We won't let you out.
Just like go to the bathroom and take a break in there.
That makes sense. And you do the
if,
same thing.
if we went into a lockdown situation, and we were supposed to be responsible for all of you all are, we think you're in the
Okay, I
bathroom.
give up.
What if our life is
Okay,
different?
I
than
give up.
you
Okay,
go to the
try
bathroom
to
when
go.
you're with
Alright.
I know where I'm going.
Hey, if everyone can focus back up here. Focus back up here. So if we did this perfectly correctly, I was a little bit off, as you can tell. I was a little bit off, but they should all come to intersect at one point. Hey, what did we call in the last section, 5.1? What did we call it when three lines met at one point? They were some certain kind of lines.
No.
They all met at the circumcenter, but that was only because we had three perpendicular bisectors meeting. So we called them
Ruined.
concurrent. Concurrent lines are three or more lines that intersect at the same point, concurrent lines. And they intersect at our point of concurrency. Now in 5.1 we had three perpendicular bisectors meeting. And so we called it a circumcenter. Here we have three not perpendicular bisectors, but what kind of bisectors meeting? Angle bisectors. Three angle bisectors meeting, okay? Once again, if I had drawn these perfectly, it would have been angle bisectors, okay? So, three angle bisectors meeting together. So, whenever three angle bisectors form, are formed, they will always meet at the same exact point. And this time, the point where they meet has its own special name as well. It's not called the circumcenter, but instead it is called the incenter. I want you to write this, okay? It would be helpful if you have a different color to use a different color, but if not,
I
you
just
can
wrote
manage
it.
with your pencil.
I wrote it all in caps.
There you go. That's called our incenter.
Yeah, for real.
Oh, wait.
See, you're good.
Okay, so wherever they intersect, it will be the incenter. Hey, do you guys remember how our circumcenter could be different places on the triangle? Okay, like if it was a right triangle, the circumcenter was on the triangle. If it was obtuse, it was outside the triangle. And if it was acute, it was inside the triangle. Somewhere inside the triangle. For this, the incenter is going to always be inside. Heads up, the incenter will always be inside. I'm going to move up down to right below this. We'll fill in some facts here. The three angle bisectors, we said these things right now. The three angle bisectors all meet at a point. We called that concurrent. We called it concurrent. The three angle bisectors of a triangle are concurrent, meaning where three or more lines meet at a point called the incenter. That's where they're concurrent at. That's where they all meet together. Make sure we're writing this down in our notes. Of the triangle. It's called the incenter of the triangle. Now the incenter The incenter can be used to draw a circle inside the triangle. The circumcenter can be used to draw a triangle, a circle around the triangle. Incenter will draw a circle inside of the triangle.
I'll bet maybe the incenter can never be outside the triangle.
Yep, the incenter can never be outside of the triangle.
Like the incenter is used to draw the incenter.
The incenter, oh,
Yeah, it should be inside.
thank you. That should be inside. Inside the triangle. Oh, excuse me.
Oh no.
I know. Sorry, RIP to those using in pen.
Oh,
The word I was looking for was inscribed, excuse me. I miswrote it. It's called inscribed. Inscribed is when it's inside the triangle. So circumscribed was it was outside the triangle. Inscribed is inside the triangle. I don't want you to write this part down that I'm doing it right now at this moment. I'm going to write down what I'm doing at this moment. Alright. Once again, if I were to able to get it perfectly, I can't quite, but I can get close. If I was able to get the perfect length on this circle would be perfectly inside the triangle right there.
Doesn't it
With that
have
being the center.
A?
What?
Sounds like an A.
My circle?
Yeah.
You kind of added up to this because this bottom ended up too flat. But if I were to able to have gotten it perfectly there to my measurement, which I can't on this compass unfortunately, then we could have made it inside the triangle. And that's what this inscribed circle is. That's what the incenter is used for. Once again, that can be used for certain things with like more engineering or architectural kind of stuff or drafting. We have this incenter theorem, just like we had a circumcenter theorem. The circumcenter theorem was where the circumcenter is equidistant from all vertices of a triangle. The incenter where the three angle bisectors meet, is going to be what we call equidistant from the sides of the triangle. So this incenter, point P, where it's all three angle bisectors meet, it's going to be equidistant to the sides of the triangle. Now once again, we measure the distance at the perpendicular. Remember, we are going to always measure distance at a perpendicular, because that's the shortest distance to something that's perpendicular to it. Alright. Now, what that's saying is PX, this right here, is going to be the same length as PY, which is also the same length as what? PZ. It's going to be equidistant to all three sides. Now, is PX a perpendicular bisector though? No, why not?
Right?
It has a right angle, but is X right in the middle of AC?
No.
Is it even close?
No.
No. Is Y right in the middle of AB?
No.
No. Is Z in the middle of BC? No. So these don't have to be perpendicular bisectors. So don't be confused when you have three perpendicular bisecting lines drawn here. That is perpendicular lines drawn here. That is a perpendicular bisector because it's not in this case. We can see by these tick marks that we have three angle bisectors meeting, and this is an incenter. And so the three distance of the three sides are congruent. Now we're going to use this in a second. We're going to use this in a second and practice it. And once again, I think it'll work. It'll apply more a little bit and stick to us a little bit more when we work on it in a second here. But before we do that, we'll take a short little detour to this, where we're going to say the rate. Yeah, sorry. I realized after I said it, it sounded like I was getting that. No, I believe this is going to turn out badly. The radius of the circle is the distance from the center to any side. So here's what I was saying where we have this incenter. And if we take the distance from this incenter to one of the sides, the perpendicular of the side specifically, it's going to be the same distance as the perpendicular to the side of the other two sides as well. P. So PE, segment PE, is going to be congruent to segment PF, which is congruent to segment PED. Could we have also put E first, F first, and D first? Sure. Doesn't matter. Well, let's flip the page. Got two examples.
We almost did it.
Okay, let's go to the next page real quick. Got two examples, and we'll be done with these notes. Okay, two examples. We'll be done with these notes. There you go. There goes enthusiasm.
Yay! We only have.
Hey, you want to do a class yay real quick? On three, we'll do a class yay. So yay on three. 1, 2, 3. Yay!
Make it like a 2-minute like
Yay.
walk around.
Not right now. The angle bisector of triangle ABC meet at M. Okay, M is our incenter. M is the incenter here. So M, that's where the three angle bisectors meet. Okay, that makes sense. We need to find the length of MJ. MJ is the incenter to what? One of the sides, correct? Okay. I hear some people saying it's 3. How do we know it's 3? MH is 3, and the incenter is equidistant from the 3.
What?
The incenter is equidistant to the 3.
Concurrent line. Oh, right angle.
3. What is AB?
Line.
Side, right? It's the side of the triangle.
Oh my gosh.
The incenter is equidistant from the 3 sides of the triangle. Circumcenter was equidistant from the vertices. The incenter is equidistant from the sides. So what's CA?
Side.
A side, thank you. So M is going to be equidistant from both the side AB and the side AC. So since it's 3 units away from AB, it's going to be 3 units away from MJ. So the measure of MJ is 3. Bonus question, what's going to be the measure of MW? 3. How do we know? Because you guys are smart, but the length to all the sides is equidistant. We didn't need to find MW, it was a bonus question for us.
Wednesday we won't. Okay, guys, I'm just gonna say this. This is a huge review for me, because I've done this several geometry classes a year for the last 5 years. And with all the side chatter that's going on, I'm confused. So for those of us who are trying to learn it for the first time, it'll be super helpful if you just be quiet, let Mr. Costle talk, and then if you have questions, raise your hand.
Thank you. I agree entirely. Example 12. Well, first of all, actually, example 11. Do we have questions over example 11? The only one we're asked to find was MJ. I threw in a bonus with MW because I wanted to drive that home. It's equidistant to all sides. Example 12. Actually, one more thing on example 11. I'm going back to example 11 here. Point M is what kind of point? What's it called? Has a special name? Incenter. The incenter is where 3 of something meet. 3, Sophia.
I actually have a question.
Okay, 1 second. Where the incenter is where 3 of something meet. What kind of line? No.
Bisecting.
What kind of bisectors?
Angle.
Angle bisectors. Angle bisectors is what this section's been about, right? 3 angle bisectors come and meet at the incenter. The incenter is equidistant from the incenter is equidistant from the what? Sides. Those are the things we need to know here. Those are the things we need to know. Sophie, what's the question?
Okay, so can there be more than 3 for
A different shape?
No, it was like a circumcenter, I think. You said 3 lines for
Oh, concurrent lines?
Yeah.
Okay, so there can be more than 3 lines for concurrent lines. It's 3 or more. But in a triangle, we'll only be dealing with a 3 because we only have 3 angle bisectors because we have 3 angles, or 3 perpendicular bisectors because we only have 3 sides. That make sense? Sophie was asking if we'll ever have 4 or more of lines intersecting. Not for triangles, we won't, because we only have 3 sides and 3 angles. Example 12. Given the incenter of triangle LOJ is C. Hey, incenter is C. Incenter is where 3 of something meet. 3 what meet at the incenter? Angle bisectors. Much better that time. So, and the incenter is equidistant from the sides. Thank you. So we're supposed to find CK, and LP. Ooh, okay, so CK we said was 6. How do we know CK is 6?
6.
CH is 6 and it's equidistant to the two sides. So we know the measure of CK is going to be 6. How do we know what the measure of LP is going to be?
Divided by a bisect. I actually don't.
Okay, what do we know PC?
Yeah.
It's 6, right? Okay. Is CL congruent to itself? Okay, if I kind of block off here, this bottom part here, this bottom section, does it kind of look like we have two triangles here?
Yeah.
Two smaller triangles? We can actually prove these triangles to be congruent. Okay, we can prove the triangles to be congruent because we have two sets of corresponding congruent angles and the sides. So we can do angle, side, congruence. So we know these triangles are congruent by angle, side. So if this is 8, this must be, once again, I was using angle, side, triangle congruence.
But wouldn't you have to like show our work every time
Like this.
on the test? Yeah.
I didn't do much showing here, did I?
No.
People are just lazy.
Well, no, like the angle sides.
Review for the test, can we do the same thing that we did last time?
No. What did we do last time?
Maybe. My answer is maybe to that. Hey, so we have a worksheet now. I'm going to pass out a worksheet for 5.2. I'm going to pass out a worksheet for 5.2. And I have some don't do's that you guys are going to want to listen for as well.
No.
What are we betting? $1.
Oh, you have one right here. Okay.
I don't think
You said bet. I give you a bet.
Thank you for collecting these sad
I don't know.
Okay, so the don't do's. The don't do's here. Eight through 11. 8 through 11. I think that's pretty nice. Okay. 8 through 11. So that means there's a total of only 14 problems on this one then. And the first 7 are vocab.
I'm not good at vocab.
If you're struggling with your vocab, where can you look for help?
No.
No.
Google.
Notes. Very good. Okay, if you're really stuck too, I guess Google, but word for word going to be in your notes. Okay, because it's the same definitions that we're using on there. You may listen to music. Let's plan on coming back together. About 5 minutes to the bell, okay? About 5 minutes to the bell, let's plan on regrouping.
Are we gonna go over the stuff that we've already done?
We'll talk about what we're doing then. So I would suggest starting with what you struggle with, so you have more time to work on that with help. Start on what you struggle with because you have more time to work on that with help. So if the vocab might be a little bit easier for you, go to the back. If the back might be a little bit easier, go to the front. So on and so forth.